Alright, in 7.2 we're talking about right triangle trigonometry. Okay, so we can define trig functions in terms of theta and the length of the sides of the triangle. So adjacent side is the closest side to theta, or adjacent means next to, it's right next to it. So for this theta right here, the closest side to it is this one right here, so that is the adjacent side. Now the opposite side is across from angle theta. So opposite from angle theta, well, there's your opposite side. Okay, now the hypotenuse is always the side opposite from the right triangle. And you can tell that you're talking about a right triangle if you have this little box right here. That always signifies that you're talking about 90-degree angle or a right angle. But always opposite of that, that is your hypotenuse. Okay, so here is our, there's three of our trig functions: sine, cosine, and tangent. Now to remember what sine is, it is opposite over hypotenuse. Okay, and then cosine is adjacent over hypotenuse, and tangent is opposite over hypotenuse. Now if you take the S, the O, and the H, that's so. The C, the A, the H, that's ca. The T, the O, the A, that's toa. So if you remember this right here, the SOHCAHTOA, that will help you to remember what it is, what's the formulas for each of these. So SOHCAHTOA, remember that, and that'll help you with what is sine, cosine, and tangent. Okay, so for this one, cosine we said is adjacent over hypotenuse. Here's our theta. So here's our adjacent side, which means this is our opposite side over here. So I need adjacent side, which is 15 over 17. And that is my final answer. Okay, sine of theta, so here's our theta. Opposite that is the opposite side. Right next to it, here is our adjacent side right here, but I don't need that for sine. Okay, so this is going to be 8 over 17, and that'll be our final answer. Okay, now tangent is going to be the opposite over adjacent. So here is our opposite, here's our adjacent. So our answer is going to be 8 over 15. Okay, now notice here our theta has moved. It was right here, but now it's up here. So that means that now opposite side will be here, and now this will be the adjacent side. Okay, it's always in terms of where is your theta. Okay, so this cosine of theta will be 8 over 17, whereas a minute ago it was 15 over 17. It all depends on where your theta is. Okay, now this sine is going to be 15 over 17 because our theta has moved. Okay, and now tangent is going to be 15 over 8. Okay, now the last three of our trig functions are the reciprocal functions. You got secant, cosecant, and cotangent. Now secant is the hypotenuse over the adjacent side. Cosecant is hypotenuse over the opposite side, and cotangent is adjacent over the opposite side. Each one of these should sound just a hair familiar. Okay, so if I take this one right here, the secant, if I had flipped it to adjacent over hypotenuse, well, that would actually be cosine. If I had flipped cosecant, opposite over hypotenuse, that's talking about sine. If I flip cotangent to opposite over adjacent, that's talking about tangent. Okay, so another way to look at your reciprocal function is cosecant is 1 over sine, or the opposite of that is sine is 1 over cosecant. Secant is 1 over cosine, or cosine is 1 over secant. Cotangent is 1 over tangent, or tangent is 1 over cotangent. They are reciprocals of one another. Okay, so if we look at this triangle right here, and we're going to try to find all 6 of our trig functions. Okay, so here's our theta, and we've already got, there's our opposite side here, there's our adjacent side, and here's our right angle, so here's our hypotenuse opposite from that. Okay, so sine will be 4 over 5, cosine will be 3 over 5, and tangent will be 4 over 3. Okay, now cosecant, what I'm going to do is I'm going to flip sine, so this is going to be 5 over 4. Secant, I'm going to flip cosine. So cosecant, you flip sine. Secant, you flip cosine. So this is going to be 3 over 5. And cotangent, you're going to flip tangent. So this will be, oh, sorry, I didn't flip this one. This will be 5 over 3, and then this one will be 3 over 4. Okay, now we need to talk about 2 very special triangles, and that's what they're known as, special triangles. You have a 45, 45, 90 triangle, and you have a 30, 60, 90 triangle. Okay, ignore this for just a minute. Okay, so in your 45, 45, 90 triangle, since your angles are the same, the sides opposite of those angles will also be the same, which they'll both be 1. Now, in your 45, 45, 90 triangle, opposite of your right triangle will be a square root of 2. Okay? Now, you can change these 45, 45, 90 to radians. Okay? So we can use, instead of 45, pi over 4, pi over 4, pi over 2 triangle. Remember, 90 is the same thing as pi over 2. Okay? Now, in your 30, 60, 90 triangle, always across your 60 is a square root of 3. Always across your 30 is 1. And always across your 90 is 2. Okay? Now, like we did in the other one, we could change this from degrees to radians. Your 30 would be pi over 6. Your 60 would be pi over 3. And your 90 would be pi over 2. It's the same thing, it's just going from degrees to radians. Okay, now if we look at this right here, we find sine of 60. Okay, so 60, that's going to be a 30, 60, 90 triangle. Okay, because what we're working with is right triangles. So if we already know that one of these angles is going to be 60, if the other one, or sorry, 90, if the other one is 60, well then this one has to be 30, because 30 plus 60 plus 90 is equal to 180. And if I add up every single angle here, it's got to add up to 180 for a triangle. Okay, so we're looking at sine of 60. So I'm looking at this angle. So straight across 60 is your square root of 3. Straight across your 30 is 1. Straight across your 90 in the 30, 60, 90 triangle is 2. Okay, now also, this is the opposite side. This is the hypotenuse, and this is the adjacent side. Okay, so sine of 60 is going to be the square root of 3 over 2. And that will be your final answer. Okay, with cosine, you're doing the same thing. This is your angle, so this is your opposite side. This is your adjacent side, and this is your hypotenuse. So then cosine is going to be 1 over 2. And that'll be your final answer. Okay, for tangent, this is still opposite, this is still adjacent, and this is still your hypotenuse. So tangent is going to be opposite over adjacent, so we need the square root of 3 over 1, which that is just the square root of 3, and that would be your final answer. Okay, if we look at the sine of 45, okay, so you got 45 here, 45 here. Straight across from both of your 45s are 1. Straight across your 90 degree in a 45, 45, 90 triangle is the square root of 2, not just 2 like it is in the 30, 60, 90 triangle. Okay, So it doesn't matter which one you pick, but we'll pick this angle here for our 45. So this will be opposite, this will be adjacent, and this will be our hypotenuse. Okay, so sine will be 1 over the square root of 2. Now, I can't leave it like that because I have a square root in the denominator, so I have to rationalize this fraction, which just means multiplying the square root of 2 times the top and the bottom. So essentially what you're doing is you're canceling out this square root of 2 times square root of 2, and that's just going to leave you with what's inside, which is just 2. And that will be your final answer for this one. Okay, same thing for cosine. We'll pick this 45. So this is opposite, this is adjacent, and this is our hypotenuse. Okay, so this is going to be adjacent over hypotenuse, so this will be 1 over the square root of 2. Same thing, we've got to rationalize, and we'll get square root of 2 over 2 again. Now notice both of these are the same exact answer, cosine of 45 and sine of 45, and we'll get to the reason why they're the exact same answer here in a minute. Tangent, again, we'll pick this one as our angle, so this is opposite, this is adjacent, and this is our hypotenuse. Okay, so I need opposite over adjacent, which this will just give us 1. Okay, for 30, okay, here's our angle. Straight across from the 30 is a 1. Straight across from a 60 squared to 3. Straight across from the 90 is a 2 every single time. Okay, so I'm looking for sine, so this is our opposite. Here's our adjacent. Here's our hypotenuse. So opposite is 1 and our hypotenuse is 2. So that's our answer right there. Now notice we went, when we were looking for cosine of 60, that was also 1/2. Keep that in mind, okay? I'll show you why those two answers are exactly the same. Okay, cosine of 30, so same thing. Opposite, adjacent, and hypotenuse. So I need square root of 3 over 2. Because the square root is in the numerator, that is my final answer. Okay, and then tangent of 30. So once again, that's opposite. This is adjacent, and this is hypotenuse. Okay, so I need 1 over the square root of 3. Square root of 3 is in the denominator, so I have to rationalize. So this will give me the square root of 3 over 3 for my final answer. Now something called cofunction of complements. If I take this right triangle right here, so I'll label it A, B, and C. So this C always, most of the time, C always represents your 90-degree angle. And then opposite of our C is smaller side C, opposite of our angle A is smaller side A, and opposite of our angle B is smaller side, or smaller B side, okay? So if we look at sine of A, so I'm looking at this angle, and sine is opposite, so A over hypotenuse, C. Cosine of B, so I'm looking at this angle B, that is adjacent, A over hypotenuse, C. They're the same thing, okay? Now since both sine of A and cosine of B are equal to A over C, then I can say that sine of A is equal to cosine of B. Since they're equal to the same thing, they must be equal to each other. Okay? Now because angle C is already 90, that means that angle A plus angle B has got to be 90. Because if I add every single angle up, that's got to be 180.